Hey everybody. So I'm going to go over the guided learning portion of this week's Imagine Math lesson, which as you can see up here is interpreting points on graphs of proportional relationships. Now we looked at proportional relationships last week, and recall that proportional relationships are relationships where the unit rate is very prominent and very easy to spot. And we also see proportional relationships on a graph as straight lines that pass through the origin, much like we see on this little graph right here. This goes right through the origin. And the origin will also be on our table. So if we had a table of values, we would see 0, 0 on that table. So again, this is the guided learning portion of the Imagine Math lesson. And like I said in the last video, if you kind of pay attention to what I'm doing here in the guided learning, it's really going to help you out on the pre-quiz. And if you take the pre-quiz and pass the pre-quiz, then you don't have to do the entire lesson. Okay, and you'll still get credit for that lesson. So let's go over this first problem here. It says drag each statement to show whether it's true based on the graph. Okay, and here's our graph here. So I'm going to pull this down just a little bit so I can see my statements. And I can see down here at the bottom, I've got 3 columns that I'm going to drag them into. I've got true, I've got not true, and I've got cannot be determined. In other words, we don't have enough information to determine whether or not that is a true or a false statement based on the information that we're given. Okay, so let's go back up to the graph real quick, and let's kind of look at what we're dealing with here. We've got the price of almonds, okay? And on our x-axis, we have weight, and on the y-axis, we have the price. So the way we interpret this red line, we can see this red line is going to the right. If we start here at the origin, which means 0 pounds and $0, which makes sense, because if you go into the store to buy almonds and you buy 0 pounds, you're going to pay $0. That makes perfect sense. So we start here and we see this line is moving to the right, which means that we're increasing the weight, okay, because it's going the same direction as this line. And we can see that this line is going up. It's as I travel along this line, I'm going up, 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 up. So that means that as the weight is increasing, the price is increasing as well. That makes sense. The more pounds of almonds I want to buy, the more money I should expect to pay. That makes sense. Okay, and we're given this point right here. And always remember that our points are listed as, let me change the color here. Our points are listed as this being the x coordinate and this being the y coordinate. I shouldn't have covered that up. There we go. That way I want to make sure I can see my numbers there. So this is the x and this is the y. So that means that for 0.45 pounds, not even a whole pound, it cost me $2.3 or $2.30. So almost half a pound is about $2.30. Okay. So let's go down here now and let's look at our options. And we see, the first thing we see is, well, let's go after the easy one, because I think we just said right here that 0.45 pounds costs $2.30. Well, I can see that right here. 0.45 pounds costs $2.30. Okay, and again, I'll remind you that this is talking about, the x is talking about weight and the y is talking about cost. Okay, so 0.45 pounds of almonds costs $2.30. So I think that is a true statement. I'm going to pull that over here, and we will check that out here in just a second. Let me get rid of this. Okay, so my next statement that I want to look at is, I want to look at this statement right here. Now, this one says 2.3 pounds of almonds cost 45 cents. Okay, now you should notice right away, this statement is the exact opposite of this statement right here. If it's the exact opposite statement, then it must be a not true statement. So I'm going to pull that over here. Okay, I know from the graph because this is weight and this is price. I know that 0.45 pounds is $2.30. It can't be the other way around. Okay. Let's now look at the other ones here. The price per pound of almonds equals $2.30 divided by 0.45. Now, if you recall from proportional relationships last week, we said that if we take the values that we're given, the x and y values, and we put them so that it looks like y over x, and this is for proportional relationships, okay, it is going to give us our unit rate, in this case, our cost per pound. So if I look at the way this is structured, $2.30, is that the x or the y value? Well, according to this up here, this is our y value. Okay, so this is a y value, and 0.45, that's our x value, y over x. I am pretty sure that this is a true statement. So I'm going to drag this one down here. And let's get rid of this. So it leaves us with two statements. It says almonds are 45 cents per pound. All right, well, that might be true, but you know what? I'm not 100% sure, but I know how I could find out. Again, going back to what we just did, we just said that if we take y over x, it will give us our unit rate because this is a proportional relationship. So if I know that 0.45 pounds costs $2.30, well, then it's just as simple as actually doing that math. $2.30 divided by 0.45, sorry. All right, so let's go to our calculator and see what that is. Oops. Let's go to our calculator and let's divide $2.30 divided by 0.45. And that equals 5.11111. Okay, so according to this, these almonds are a little over $5 per pound. They're not 45 cents per pound. Okay, they're not 45 cents per pound. All right. So I think we need to drag this one to the not true statement. And our last statement says the weight per bag of almonds is 2.3 pounds. Okay, I don't see anything over here that is telling us that information. Okay, it is very possible that the bags are 2.3 pounds. It is very possible. But the problem is that our graph here does not give us that information at all. So I think we have to put that in the cannot be determined column. So I'm going to drag that over here. Now that I've got these in place, let's see if I am correct in my thinking. I hope I'm correct in my thinking. Let's check. Yes, we are correct. Okay, and we can see here the justification for everything that we're saying. Okay, we're saying 4.5 pounds of almonds cost $2.30. That's what this point right here tells us. Okay, 0.45 pounds up to $2.30. Okay, true statements will represent the information on the graph. Right. Okay, the next statement that was true was that the price per pound of almonds is equal to $2.30 divided by 0.45. And remember, we actually did that on the calculator. Okay, we said that with a proportional relationship, we can divide the y coordinates divided by the x coordinates, no matter where they are, and it will give us our unit rate. And that is what allows us to say that the statement right here that almonds cost 45 cents a pound, that one is incorrect. Okay, we're able to say that because of this statement right here. Okay, so let's move on. Okay, we said that this statement right here is not true. 2.3 pounds of almonds cost 45 cents. We said that's the opposite statement, right? It is this right here. If the graph was switched, then, or if it was 2.3 pounds for 45 cents, then notice that this 2.3 would have been over here on the x-axis and the 0.45 would have been on the y-axis, but that's not how it's written. Notice right here, the coordinates are switched. Okay, this was our original coordinates. This is how it was written. This is how it was given to us in the problem. So this is the one we have to go off of. This is a switch. So that one is incorrect. Okay, and well, we said earlier that the cost per pound was $5.11. And the last one here, cannot be determined. Okay, statements whose truth cannot be determined will include information other than the weight and the price as represented in the graph. Okay, our graph only represented the weight and the price. the how many pounds cost how much. It didn't say anything about the bags of almonds, anything like that. So that's why it cannot be determined. Okay, so let me clear all of this out. Let's clear all that, and let's go to our next question in the guided learning. And we have this question right here. Which graph could represent the price of a fence selling at a unit rate of R dollars per foot? Okay, so we're saying we don't know how many dollars. We're just calling it R dollars. Okay, so our unit rate is going to look like R dollars per 1 foot. Okay, this is a unit rate because it has a denominator of 1. It's the cost for 1 foot. Okay, so now remember we said with a proportional linear relationship with all these R, notice these graphs all go through 0, 0. With a proportional linear relationship, it's always y over x. Okay, y over x. Okay, so that being the case, if I set this up as a point, because notice, look, guys, look, all of these right here, they all have a point associated with them. Okay, and I don't know what R is, but I do know that this right here, this 1 foot, is an x coordinate. So that means that this is a y coordinate. So if I set this up to look like a point, it's going to look like 1 comma R. Now, which one of our graphs shows us 1 comma R? Well, it looks like to me like it is this one right here. Notice this one says RR. So this one's comparing dollars and dollars, because remember, R is dollars. This one's comparing RR. So that's dollars and dollars. This one over here is comparing dollars and feet. Okay, but we're not comparing dollars and feet. We're comparing feet and dollars. That's the way this is set up. So let's check it. And we are correct. Correct, Amundo. And oops, let's listen to the lady tell us that we're correct.
Wonderful. This graph shows a unit rate of $4 per foot.
Which we already knew, right? Okay, guys, there we go. There's your guided learning. If you can handle those 2 questions, then I am pretty sure you're going to be able to handle the pre-quiz and pass it on the first time you do this. Okay? Good luck.